Greetings. We're finishing up our discussion of graphing rational functions. Remember, rational functions is the ratio of a polynomial and a polynomial. Okay, so just think of it as a function. You've got variables in your numerator, variables in your denominator. All right, so let's look at situation number 3. Remember, we're evaluating the degree of the numerator and degree of the denominator. In this case, our n is greater than our m. All right, let's go back to the other two situations. If m was less than m, okay, you had a horizontal asymptote at y is equal to 0. And if m was equal to m, then you had a horizontal asymptote at a divided by b. Okay, so now we have a third situation. Our degree of the numerator is greater than the degree of the denominator. Now I've graphed this particular function and this looks very different. Okay, it does appear that I have a vertical asymptote. I had to zoom in on this graph so it's hard to see what the x value is for that. But remember, vertical asymptotes, that rule is easy. That rule just says what makes our denominator 0. In this case, the value x is equal to -3 makes our denominator 0. That's where this vertical asymptote comes from. All right, so remember our standard form. So now we're looking at n is greater than m. Our degree 2 is greater than our degree 1. So when we do that, okay, it turns out we have no horizontal asymptote. So if m is greater than m, there is none. There is no horizontal asymptote. But what is, it looks like there's a line here, okay, a diagonal line that's acting as a asymptote. Okay, so this is called a slant asymptote. Okay, think of slant as a diagonal line. Okay, we have a slant asymptote. This can happen when the degree of the numerator is exactly 1 greater than the degree of the denominator. Excuse my writing again, this was an m down here, when n is greater than m. Okay, if this number is exactly 1 greater than that one, in this case 2 is 1 greater than 1, then you get a slant asymptote. Okay, now how do you calculate the slant asymptote? We want the equation of this line, so we're going to do a little bit of polynomial division. Okay, remember long division? Well, there was a shortcut for that. Okay, it's called synthetic division. Remember, you're going to use the 0 for the denominator. The 0 is -3. Okay, now we're going to use the coefficients of our terms. Our x squared coefficient is 1. Our x coefficient is 0. Remember, there's no 0 term, so you have to put this in here. And our constant is -4. Do a little polynomial division. Slide that down, which is 1. And you're going to multiply, add, multiply, and add. Okay, when you're looking for the slant asymptote, we don't care about the remainder. We don't care about the remainder. We care about the equation of the line. We started with an x squared, so that means this degree is 1. So think of it as 1x to the first minus 3. 1x to the first minus 3. Okay, easy way to say that is x minus 3. So the slant asymptote is the equation y is equal to x minus 3. Okay, we have a slope and a y-intercept. If our y-intercept is at -3 and our slope is 1, it creates this blue slant asymptote line. Okay, this is something you definitely have to practice at. You may not understand it perfectly the first time. Okay, so a quick review. If m is less than n, we had the horizontal asymptote y is equal to 0. If m is equal to m, we had a horizontal asymptote where we took the coefficient A and divided by the coefficient of B. And if, in this case, n was greater than m, we have no horizontal asymptote, but it could be that you have a slant asymptote, and you're going to use polynomial division to find the equation of that slant asymptote. Hope this helps. We'll talk about the graphing of this a little bit later, how we get all these exact points. For now, think of it as got to do the work to do an input-output table to find out where your points are going to go. Talk to you soon. Thanks for listening.